Hello friends, welcome to Electrical Design Engineering YouTube channel. This is ninth question of our video series Electrical Interview Questions and Answers. Here we tell answers of various questions which are helpful to crack interviews for operation and maintenance of transmission and distribution lines up to 800 kV, rural electrification, revamped distribution sector scheme that is RDSS, electrical substation design and operation. Before starting today's question, please subscribe the channel, like the video, share the video on your social media profiles. Let us start today's question. Today's question is how to find current of any three-phase distribution transformer. Here you have to tell how we can find a current of any distribution transformer, or you are saying interview ask you what is the current rating of any particular transformer, say suppose 250 kVA, 63 kVA, or 400 kVA. Now, how you can find that current of any transformer from HT side or 11 from LT side? Distribution transformers are generally 11 by 0.433 kV. That means the primary, that is the HT side, is that the primary side is 11 kV, and the secondary side, that is LT side, is 0.433 kilovolt. That is the line to line voltage. I will tell you different currents of various transformers from HT side and LT side one by one. Here you can see this is the distribution transformer, then there is a current on the HT side, then there is a current on LT side. For 25 kV, the current on HT side is 1.31 amperes. For current on LT side is 29.3933. Similarly, for 63 kV, the current for HT side is 3.31, and for current on LT side is 24. Similarly, for 11 kV, for 100 kVA transformer, the current on HT side is 5.25, and the current on LT side is 133.34. Similarly, for 250 kVA, the current on HT side is 13.12 amperes, and current on LT side is 333.34. Similarly, for distribution transfer of 400 kV, the current on HT side is 21, and the current on LT side is 533.35 amperes. Similarly, for 630 kVA transformer, the current on HT side is 33 kV, 33 amperes, and the current on LT side is 840 amperes. Now, how you can find the current? If you are given some transformer and you do not know what is the current on HT side and what is the current on LT side, how you can find that? Suppose we will take a 250 kVA, 11 by 0.433 kVA. It is not kVA, kilovolt distribution transformer. Sorry, here is a mistake. It is 11 by 0.433 kilovolt distribution transformer. And we have to calculate what is the current on HT side and what is the current on LT side of this transformer. That is a 250 kVA. Voltage, line to line voltage on primary side is 11 kV, 11 kilovolt, and the voltage on line to line on the secondary side, that is the LT side, that is 0.433 kilovolt. Current of any distribution transformer or any transformer is equal to current on HT side, that is the primary side, is equal to capacity of a transformer in kilovolt kVA divided by root 3 into voltage, line to line voltage in kVA kilovolt on primary side. Suppose for current on HT side, we have a transformer of 250 kVA. So capacity of transformer is 250 kVA divided by root 3 into line to line voltage on primary side is, that is HT side, is 11. So we have written 11, it becomes 13.12 amperes. Say whatever we have shown you in the previous slide. Similarly, the current on LT side is equal to capacity of transformer in kVA divided by root 3 into voltage, that is line to line voltage in kVA on secondary side, that is equal to 250 divided by root 3 into 0.433, that is the voltage on secondary side. is equals to 333.34 amperes. Here you can see one thing. Current on HT side is equal to capacity of transformer and divided by root 3 into voltage, that is the line on our primary side. The primary side, we are calculating the current of primary side. Similarly, we are taking the voltage of primary side, that is equal to 11 kVA, and that gives 13.12 amperes. Similarly, you can see here the current on LT side is equal to capacity of a transformer divided by root 3 into voltage on secondary side, that is 0.433. It becomes 333.34 amperes. Thank you.